on. So there is still room for improvement. And if you have any feedback at the end of this session, I will gladly take them in. So yeah, work in progress, but everything can be found here. So these are the type of images that you can expect from the simulator. So we have multiple different sequences as of now. So we have a spin echo, gradient echo, inversion recovery, double inversion recovery, FLAIR, diffusion, SSFP, and 3 different type of turbo spin echo with 3 different K-space trajectory, linear, out, in, and in, out. So these are the type of images that we can see, and the structure of the brain is a bit more elongated. This is due to the low field gradients. So there's some of the distortion that you would not typically see in a 3T or 1.5 typical MRI. So then you have all of the different steps on how to actually apply the simulator on your computer. And so due to the lack of space on the GitHub, we had to put some of the data on the Google Drive. So you just need to download them from here. And then it explains how you can run the simulator. And you basically just need everything in the same folder like you would have here. And then once you have this, it's very easy to run it. And if for any case you don't have any experience with coding, or you don't have Python, or it's not your area of expertise, or you have some bugs, we also created what we call the executable, which is an application where basically you can run the simulator from this application, and you don't need to install Python or whatever. It just takes a little bit more time to open. And as of now, it's only usable on Windows. Since I'm working on a Windows system, we're trying to look at how we can implement it on Mac computers. But we also have a wine bottle website right here, which basically allows you to open Windows system on Mac computer. So you have different type to play with the simulator. This is what it looks like, but I'm going to show you this later on in more details. And yeah, so I'm just, sorry, the Zoom windows over here. Okay, perfect. So I'm just going to run it from the code because it's a little bit faster on my computer, but you can do this again from the executable. So you just run the script, wait a few seconds, and then this image should pop up. Do you see what I'm seeing? So the simulator, or are you still on the website?
We can see the simulator.
Okay,
Can see the simulator.
perfect. Thank you. So when you open the simulator, the first thing that happens is you can decide either you want to go to the simulator or you want to go to the generator. We'll start with the simulator because it's basically where you can. So this is more an educational area of our software, where you can play around, play with the parameters, the different sequences, and interact with the data. And then the generator is basically the same thing, but this is just for generating lots of data set that then you can use for presentation, or if you're studying some denoising, or if you want to apply some, or to test some machine learning. So this is more, yeah, like it's everything is in the name. So to generate data sets versus if you want to have a better grip of the parameters in the MRI. So if we go to the simulator, the way it works is we have some predefined maps. So everything is done in 3D. But if, for example, you would build your own low field system, or if you want to understand the impact of changing, for example, a B0 magnetic field or T1 or T2 values, you can import your own maps and then see the effects. So I'll show you this a bit later on. But if you just click on Open the Simulator, you will use the predefined maps that are stated right here. So once you open the simulator, I'm just navigating through the different Zoom windows. So this is how it looks like. We try to make it as close as possible to, for example, a Philip or a regular MRI system. So you will have your 3 different views, sagittal, coronal, and axial. On the top left, you have all the different sequences that you can choose from. Then you have some scan parameters that are appropriate to the, for example, the SNR or the scan duration that you would have for specific parameters. And then you have all the different parameters that you can play with. Just moving the zoom window, perfect. And then we also have some basic post-processing options and some parameters visualization. So I'll get into this a bit later on. So I'm just going to go back to the tutorial. So when you open the simulator, you have a small tutorial that I made, which is composed of 26 slides that you can navigate through, and you can come back and you can exit at any time. So this, I thought it would be like a good idea to just go quickly through the tutorial, and so then you have a global idea, and then we can do sort of a live demo where either you can ask me to show you some stuff, or I'm going to show you the basics, but then if you have any question, we can go into more details. So first thing to know is that sometimes when you move through the on the window, you will have some little information coming depending on where your mouse is. So for example, here I'm on the gradient echo sequence, and we have some little information regarding this regarding this sequence. And so this is just to let the user know, for example, just to get the user a bit more information about where what the user is about to run. And in some cases, when on the bottom it says for more information, right click. If you right click, this will open a website dedicated to give you more information in more details on the topic. And this is done in different areas. Also, for example, on the filters application. So this is to get as much information as possible to the user. So then it's pretty straightforward. So, oh, sorry, just before the straightforward. Sometimes when you go through, for example, the sequences, you see you have all of these little information boxes that come underneath. It's a weird thing that I haven't figured out how to solve. But basically, if your mouse comes from the one prior underneath, you're not able to press the button. So, for example, now on gradient echo, there's no little box underneath. So you just need to move out and then come back in. So it's just this little technicality that sometimes, yeah, it's due to like a Python thing. So not to be alarmed if, for example, sometimes you click on it and nothing is happening, just go back, just go out and go back in and it should be fine. So this is what I told before, like the different frames of the simulator. And if we go through them one by one, so it starts with the sequence. So we can define any of those sequences that we want. Let's say, for example, gradient echo. So then this is a small label letting us know what sequence we've selected. And as you can see here, we have the different parameters that are in accordance with this sequence. So now let's say, for example, we choose a different sequence. Let's say it happened, okay, a turbo spin echo. We can see that the parameters change with this sequence. So it's a bit dynamic, I would say, in that sense. And each parameter has a little bit of more information on what it means. So now if we just take, for example, with the gradient sequence. So once we've selected one, then we can, this is what I said before. So then we can change any type of parameters that we want, and we can just run it. So if we, for example, follow this tutorial, we can put, for example, 50 here for the TE, and let's say then we just run the sequence, wait a few seconds, and the images arrive. And so in the tutorial, I just made everything with a spin echo, but it's exactly the same thing. And so then once you have your sequence, let's say you're happy with your gradient echo, but you want to go a little bit into more detail into what is happening. Then we can look at either the post-process or the parameter visualization. And both frames can be open and closed with right or left clicks. So just opening one or closing both. So the first one in the post-processing, we have different filters. And this was in order to get the user an idea of what it meant, for example, to denoise some low field images. Because as you can see, there's a lot of noise in the low field. And one option to remove this noise is to apply some low field filters. So we have two of them, three actually. One is the low field pass, another one is a Gaussian pass, and the last one is a non-local filter, which is a little bit more refined. Here are the parameters for each of the filters, and let's say we apply the low field pass, and now we can see that the images change accordingly. So for those of you who don't know what a low field pass is, it basically smooths an images. So as we can see, it blurs a little bit, but we have less noise. And then if we do a high fill, it's the opposite. We're detecting edges. So then the images will look a little bit more like this. And you can also see that on this little box here on the left, we have what is called a sequence and filter history. So this little box here keeps track of the 5 last sequences that were run by the user. So in this case, we first started with a gradient echo with these values for the TR, the TE, the T, for these parameters. Then we applied a low pass with a kernel size of 3, then a high pass with a kernel size of 3. Let's say, for example, now we change the value of the low pass and we apply it, then we would update this little filter history. If you want to come back, kind of back in time and to one of the earlier sequences, you can just left click on any one of them. So now I left click on the first one and we're back to where we started. If I left click on the low pass, on the first low pass I applied, then we're back on it. So this is just to keep a bit track. For example, you're testing some filters or you're changing some parameters. Then you want to remember, oh, what did I did before? You have kind of like a little history right here. And I think actually maybe I don't need to follow the tutorial here because it's maybe a bit more fun to have it everything interactive. But so everything that I'm going to show you now, everything is in this tutorial, and you can always come back to it at any time. So I'm just going to quit this. Okay, moving the Zoom window, perfect. So these are the filters that we can apply. The non-local filter is also a low-pass filter to reduce the noise. It takes a little bit more time, so I'm not going to run it now. But it's also to remove the noise from the images. And when speaking about noise, is all these little dots on the background and on the inside. And one way to measure the noise is what is called the SNR, which is this value right here. And the SNR basically is defined in our case with 2 boxes. And you can always visualize where these boxes are to understand where does this number comes from. And for that, we have the visualization SNR button. So if we click on it, this image shows you how the SNR is computed. So this number here is the mean of this box divided by the standard deviation of this box. And there are multiple ways of defining the SNR. We decided to use this one. And I'm just seeing in the chat that there are. That's a great research student. I'm affiliated. Is that dashboard from any brand? So thank you for your question, Alex. I'm not sure I understand it. Do you mean the basic outline of the simulator? Is it from Philips? Is that your question? Or if that was your question, so the idea that we had was so the one that we're using in Leiden for the 7 Tesla had this layout, and it was from Philips, if I remember correctly. And we just wanted to make it For example, if a doctor or clinician is using this simulator, to make it as familiar as possible with some of the other classical MRI dashboard that they are. So if that was your question, let me know, or if I didn't answer it, or if you like more detail, please let me know. So coming back to the SNR, so this is how this number is defined. But again, to let the user to have something that is as interactive as possible, we also have what is called a measuring SNR button right here. And so if you click on it, this shows you the actual image that is on display right now. So this is the gradient echo that we have. But if we would have run, for example, a diffusion or an inversion recovery, the image right here would be a diffusion or an inversion recovery. And what is happening now is basically something that is a step-by-step interaction with the user. So as of now, there is no boxes to define the SNR. So if we just right-click to start, then we need to select the center of the box for the standard deviation. So we can click anywhere we want, left-click, and this will define the box used for the standard deviation. So let's say we want to put it, for example, here. Then we right-click. Now we need to select the center for the mean box, so the box where we have the mean of the signal. And then again, we can click in different spots, and we see that the SNR of the image changes with respect to where we are. So if we are outside, we're going to have a very low SNR, and if we're inside, we're going to have a very high SNR. So this is to get the user to kind of play around with the SNR and see how it's defined. And what does it mean if you change the box's position? And also, now if we right-click, we see that we also have a slider here underneath. And if we change the value of the slider, it's going to change the box's size. So we can also see how the number changes with respect to this feature of the boxes. So we have the box's position and the box's size. And let's say we're happy with this. So now if we just quit, you see that this number has updated itself. And now if we visualize the SNR, the boxes have changes from before. So whenever the user wants to define a new SNR, new position or sizes of the box, you just need to click on the measuring button, and then you can change it. And then every new images that you will run, the SNR will be defined on these new boxes. And now let's say, so you're happy with the way the SNR is defined. You apply one of the low pass filter, and you see this image, but you're like, oh, wow, it's really big. I wonder what does it mean to changing this number? So let's say before I had like 3, and you want to just have a little bit more detail into what is happening. So we go back to our gradient. We can rerun a sequence just to get the images from the start. And now if we go to this frame, so the parameter visualization, these are the 3 different filters that you can play with. We didn't include the last one because, as I said before, it takes a little bit more long to run, so it's not as interactive. But so let's say you want to investigate the low pass filter. So if you click on low, this image will appear. And what is happening now is this is a fully 3D interaction with the data. So if you scroll, you will actually go through, for example, here, the sagittal slice, because the action is used on the sagittal axis. If you just click on the arrow on the right of your keyboard, now we're on the coronal slice. So we can go through the coronal slice, and then same for the axial slice. And so what we're seeing right now is the same images from our gradient sequence with the filter applied. Moving the zoom window, and you see here on the bottom that we again have a slider. And if we change the value of the slider, it basically changes the kernel size of the filter. So we can see in real time and interactively what does the filter does to our images. So this is to get a deeper sense into what does it mean to apply a filter. in this case, the low pass. And also, every time we have an interactive window, if you just take your mouse and left click, and then you move up or down, you will change the intensity of and the brightness of the image. So this is kind of a nice interactive feature to understand what a 3D data set is. And if you want, you can also go to this little corner here on the top and use crossline. And this makes almost like on a real system. If you move your mouse, so now we're on the actual slice, but this can also be done on the two other ones. Depending on where your mouse is, you will have these two white lines that indicate the two other sagittal and coronal slices where they are. So if I move my mouse down, then the sagittal slice doesn't move too much, the coronal one does. And so this is again to have a better understanding of what does it mean to go through the 3D data set. And then you want to not use a crossline again, but you're a bit stuck because since you move your mouse out, you don't have anything on the sagittal or coronal. You can do the same thing by just right-clicking where your mouse is. So now my mouse is here in the middle of the brain. If I right-click, the images of the sagittal and the coronal will move accordingly to where my mouse is. So if I put my mouse a bit more up front and I right-click, then the coronal slice changes, but not so much the sagittal one. And if I go to the left of the brain, so this is just another way of knowing what is happening. And so this can be done for each of the three filters, but also for the sequences. So in this case, we're using a gradient eco-sequence, and we have these parameters. So if we click on the visualization of the parameters, so it just takes a little bit of time because it's rerunning the sequence, we have the same type of window popping up with, again, the same interaction possible. So if we just scroll through or we move, so this is all the same as before. But this time, for the sliders, we have the parameters. And if you change any of the parameters, the images will change accordingly. So this is to get a deeper sense into what does it mean to actually play with the MRI parameters, which, to be honest, I'm not a pro. And so for the case of the gradient echo, we can see that depending on the parameters, we have an illustration of the B0 not inhomogeneities in the low field. But if we use, for example, like a different sequence, let's say spin echo, we will have different parameters popping up. So I just ran the sequence and I come back to the visualization. So this time we only have the TR and the TE. And we see again that we have different output depending on what is happening. One thing also is that the way we coded our sequences, so if we now look at an inversion recovery, sometimes we set the parameters. So the reset button and so the reset image and parameters button does exactly what just happened. So the images will reset to the model we're using, and all the parameters will just come back to the original ones by default. So now I'm just going to run an inversion recovery, and the way we coded it is just when you're using the simulator, every sequence that are using a turbo spin echo readout take a little bit more time to run, as you can see now. So I pressed the run sequence button a couple of seconds ago and nothing is happening. It's just because I'm not the best coder in the world. It takes a little bit of time to run. So don't be alarmed if you're using, for example, any sequence that has a turbo spin echo readout or the turbo spin echo, which is half of the sequence. So it just takes a little bit of time and then it will appear. Hopefully, here it is. So this is just to let you know, don't be alarmed if it takes sometimes a little bit of time. It's normal. And so let's say, for example, you're happy with your image. you want to save it, you can save the images here, and this will be saved as a JPEG format, if I remember correctly. So if you just click on save, then it will open a search window, and you can go wherever you want to save your data. So I just created an empty folder here. And if we just, for example, like that. There we go. So now in our save data, oh, I'll need to double check something is not working. Oh, okay, here it is. So in our save data, we just saved the sagittal view of our image. So the sagittal view is this one, so we just saved it. In this frame, we only have this option to save one image because, as you will see with the generator can save lots and lots of data sets that then you can have. So this is more for just one quick image for a presentation, for example, or yeah, just something to put on a poster or something like that. So this is just a quick and easy way to saving one image as a PNG. So now this is these are the basic sequences option of the simulator. As you can see here, the last thing I wanted to talk to you about for the simulator was this part. So we have that the magnetic field strength is 46 millitesla, which is the low field strength. But we also wanted the option to be able to simulate different field strength. So if you click on settings, this window will appear where you have different information. So each row is a different value. The first one are the B0 fields, second ones are the T1 values, and the last ones are the T2 values. And the columns are the different field strength. And basically, if you click anywhere, oh, is there a question? Or, oh, okay. If there's a question, let me know. I heard something. So if you click anywhere,
carry on. You can continue.
Okay, perfect. So if you click anywhere on the 46 millitesla column, you will use everything that is predefined for the 46 simulation, which are the B0 field with lots of inhomogeneities, the T1 values, and the T2 values. But if you click anywhere on the 1.5 Tesla column, you will see that then this little label will update. And now we're using the 1.5T. And this doesn't matter if you click on the T1 value, the T2, or the B0. So now I'm clicking on the 46 millitesla B0, it changes. Now the T1 value for the 3 Tesla, it changes. And so if we then keep this, so we close the window, now we're going to simulate something 3T. Just going to use the Spinnaker because it's a little bit quicker. And now we will have a simulated 3T image. So we can see that we have much less distortion in the brain because we don't have a strong B0 inhomogeneities, as well as a lot less noise in the image. But then everything works the same for the filters and for the visualization of the parameters. So again, it's not the most intuitive way of doing it. We're still thinking of a more easy way, but we wanted the user to know what was changing if you wanted to use a different field strength. So basically, these 3 maps are what are changing in the calculation and the background. So if now we're using the 3T, the T1 and T2 values relaxation are changing, and the B0 field. If we're using the 1.5 Tesla values, same thing. The T1 and T2 are changing, and the B0, and same for the 46. So now, once you're happy with the simulator, you've seen everything. So now we're just going to rerun a small last sequence. So you kind of you're happy with what you wanted to understand or experiment. Then if you want to exit the simulator, you just click here and you can go into the generator, where basically what is happening here is the same thing. So once you open it, we again have a tutorial that I think maybe I'm going to skip because it's more fun to have something live, but that explains everything that you can do. And what you can do is the following. So it's again kind of the same layout where we have 3 different images here in the middle. As of now, nothing is shown. We have the different sequences that we can generate, our parameters, and then we can create our data sets. So, for example, I'm going to do a spinnacle. If you want to change any parameters, you can do them here. And I want to create a data set. So here I'm in the single data set generation. What is meant by this frame is that we're always going to create a pair of data sets. One pair of the data set is going to be with no noise, what we call high SNR, and one pair is going to be with noise, which we call low SNR. And you can adjust the noise factor here. So if, let's say, we put a noise factor at 3 and we create a data set, what you see here on these images, so sagittal, coronal, and axial, are the pair of data that you just created. On the top row, we have the 3 different views for the data you just created with no noise. So this is the high SNR dataset. On the bottom, you have the low SNR dataset. And if we go to an extreme, for example, a noise factor of 5, you see that we have a very big difference between both of them. And you also have like a small label that tells you once you have created your data, when it's done, basically. And then if you can visualize both of your data sets. So this is again an interactive window where you can slide through. And you have on the left what we call the clean data, so the very high SNR data with no noise. On the right, noisy data, low SNR, and a lot of noise. And if you just press on the space bar, then you will change your different your position to view your data. So now we're going through the sagittal view. And lastly, the coronal view. And again, if you want to right click and move your mouse, you can change the brightness and contrast on your images. And let's say that for the purpose that you wanted, you're happy with these two, so with this pair of data. Then you can either save your data as a NumPy array, so basically a matrix, or you can save it as a Nifty file. No matter which one you click, you will have this search window that will open, where you can scroll through your folders, and you can select one. So I select the save data. Once you've done this, it will save your data. And if now we go into our saved data folder, we see that we have the test image. So that was the one from the simulator. And now we just have the Nifty files that we just saved. And we have 2 Nifty files and 1 text file. The text file is just a recap of all of the parameters that you used for this sequence. So these are the resolution, field of view, all the values for the different parameters, yeah, everything. And then you have your 2 Nifty files, which is one noisy and one clean. And these just refers to high SNR or low SNR data. And then you can use your data for whatever you would like to do. And I'm just going to delete that for the next save, because it's going to be much easier to see. And so this is all nice, but let's say that you don't want to do this process every time you run a new sequence. So now we go to the gradient echo, we create a data set. It's a bit lengthy to do this every time to go to this, all of these little buttons. Let's say you want to save lots of data set at the same time. you can go to this frame right here where you can generate and save multiple data sets. And to that, you just need to add the sequence that you want to what is called a list. So let's say we want to add what we just created, the gradient, to the list. So we add it. So now we see that in the list, we have right here, GE, which is gradient echo, and these are all the parameters that we're using. So now if we go to the spin echo that we wanted before, but we want one which is, let's say 3000 TR, 160 TE, we add it to the sequence. So now we have a second line, which is SE for spin echo, and the parameters are changed. And then let's say we want, again, a spin echo, but with different parameters. We add the sequence, we have a third one. You can also view this list with this button, and this will just basically output the same thing, but on your Python terminal. So this is just another way of seeing things. Once you're happy with all the sequence that you want to generate, you just click on create. And this takes a little bit of time because it's creating all of your data sets. But once it will be done, this will these two labels will appear. So sequence 3 on 3 has been done, and everything has been created. And now you have, like for the single data set, different options. You can visualize your data, but since we created 3 different data sets, we need to select which one we want. So let's say we want to visualize the first one. This is the first sequence that we have created, which in our case was the gradient echo. Then we can go to the second one to visualize, and this was a spin echo. Then we have the last spin echo, but this time with different parameters. And so this is to see everything that you've created. And once you're happy with all of that, you can again save them either as matrices, so NumPy arrays, or Nifty files. This time I'll do the NumPy array for the difference. So you just click on the folder where you want to save them, and then everything is in there. So this time you have, for each of the sequences that you wanted to create, in our case 3, you have a clean sequence and a noisy sequence. So this is why we have sequence 1, 2, and 3. And for each sequence, we have the text file that repeats all of the parameters that you had in there. And then you can also do the same thing, but for not only the 46 megatesla, but for the 1.5 and the 3 Tesla. And I think that this is everything from the simulator and the generator. So if you have any question, let me know. If you would like some if you would like to see something else, let me know in the simulator or in the generator. We can go, I can show you more details. So yeah, let me know if you would like to see something else or if you have any questions.
Yeah, I think it's a great presentation. And one thing about the simulator is like, as you cannot take your real scanner to the house, I mean, this is a platform that you can take it home and just play with the sequences and the parameters and see how it affects the image contracts. And yeah, it's a great opportunity if we will have this on our laptop. So my question is, how can they access this simulator?
Yeah, so the simulator, so I'm just gonna quit this. So the simulator can be accessed via my GitHub, which is completely free and public. So you don't even need, I think, a GitHub account to go look for it. And then either you can get it, if you know some programming, you can then just take the code and have Python, and then everything is explained on how to run it. Or if you have a window, you can use this link right here, which basically lets you download the executable. So this is the application. So you don't need any code for using this. And if you have a Mac and you still want to use the application or the executable, you can go to this website to try to, so this wine bottle is basically a software that allows you to run Windows program, but on Mac. So it's a little bit tricky to create applications for Mac if you're working on a Windows. So this we haven't have a solution yet. But if you want to use the simulator, where to find it is on my GitHub. But we can also think for a second version or a third version to have something interactive on a web page. So then the user just need an internet connection. So this can also be, yeah, stuff for the future. But
That's awesome. So yeah, the platform is yours. If you have any questions, you can ask. Yeah, Matthew, I think we also spoke about trying to incorporate the ASL. I don't know if you can just give us an idea or an update on that.
so for the ASL, I had a little bit of time off and I thought it was going to be a very easy and straightforward project. But since it's taking a bit more time to finish the details on the simulator, and as I said before, a little bit of work in progress, we started the publication, but we still have some small details. I don't have the ASL implementation yet. So as of now, I don't have something concrete to show you, but that would be the next stage for the next stage to have it run, I think.
Yeah, that would be great.
Or whatever you think, what would be the best thing to have first, the ASL or to have the simulator on a web page? So then no matter if you use it from a Windows or from a Mac, everybody could access it to be
yeah, and the good thing is it's open access and you don't need to struggle to get it. And once the update comes, like you go there and you can see it.
And for everybody listening, we also have with Francis talked a lot about the different issues one's could have when you run the code. So we have kind of like a logs of all the different errors that if you encounter them, we could also put this on my GitHub. So if you have some problems with running the code, you could also go to this log to see if previous person had some problems. And I also created some little files. So for example, the structure of the main Python codes. So you have in there if anybody wants to tweak the code or play around, they can also use this. So this is just to see where in the Python, in the coding files, what is done where. So then if you want to change some stuff, you can also use that. Yeah, so
Good
it's
stuff.
like I said, open
Yeah.
project. So
I always say the best way to learn is to keep practicing. Just do it. Yeah, and once you have this, not like the scanner, you can take it anywhere and just practice it and see how, yeah, it works. And the good thing is the information are also there, like the sequences. When you highlight on it, you can just click and it will lead you to where the sequence and the concept and everything, and you'll be able to read and understand it well. So yeah, I think that's awesome. That's good.
yeah, it was one of the main goals to, if you want to practice with on a real scanner, sometimes it can take some time. You need a volunteer or a phantom that you don't have. And we wanted to kind of bypass this a little bit and to offer any user as much a limited time of practice, basically. So it's mimicking reality, but it is not reality. So we're trying to get as close as possible.
Yeah.
But it's, as of now, this is where we are. Still room for improvement, but yeah.
Good. Any question? Matthew is still here. If you have any question, you can ask.
Looking at the chat, maybe I can put in the chat the link to the GitHub if you're looking for it. There it is.
Yeah. And I think the GitHub address is on the chat in case you want to access it and have it on your computer and then just play with it. You just put it on the chat.
And if you ever have like questions in the future, or if something is not working, or it's a problem or whatever, you can always email me, or yeah, always available.
All right. Thank you very much, Matthew, for your time.
Thank you for having me.
I'm very grateful for that. And yeah, we will just go and then play with it. If you have any issue, we will come. So yeah,
Great,
this is
thanks.
where I think we can end if no one has any question. All right. Thank you once again. And
thank you, everybody.
bye-bye.
Bye.